Let's do question 10A2. Let's read the information again. A pool is being filled up by a hose pipe. The rate of flow increases by 10% each hour, and the table below illustrates this process. So we have the table there. Then says if the hose pipe above is filling up a pool, then how many liters of water will be in the pool at the end of 24 hours, assuming the pool was empty at the start of the process. So this is the key here. We're looking for the liters of water that will be in the pool at the end of 24 hours. So now we have to be careful here. So this is 1 liter per minute. 1 liter per minute. It means at the end of 1 hour, how many liters do we have? We have 60 liters, isn't it? Because in 1 hour we have 60 meters. So 1 liter per minute means we have 60 liters. Right, 1,1 liters per minute, it means 66 liters of water. 1,21 liters per minute, it means in hour 3 we're going to have 72,6 liters from 1,21 times 60. And then 1,331 times 60, we have 79,86 liters. So these are the liters that we're going to be having in each hour. The question says, if the hose pipe above is filling up a pool, then how many liters of water will be in the pool at the end of 24 hours? So it means you're finding what? The sum of these terms here. This is geometric series. So we're going to use the formula Sn is equal to A and then R n minus 1, R minus 1. And then we're looking at the liters, not the rate, the liters. So A here is equal to 60. Then R, you can do that. You can say 66 divided by 60, you'll get 1,1. 72,6 divided by 66, you get 1,1. 79,86 divided by 72,6, you get 1,1. So R is equal to 1,1. And then N is equal to 24. Right? We substitute into the formula. So S24 is equal to 60. Then R is 1,1 to the power 24 minus 1. All this over 1,1 minus 1. Then you can put this in the calculator. S24 is equal to 5,309,839605. Right, and then this would give us 5,309,84 liters. Okay, that's question 10A2.